Hi, I'm Rainer, and this week we're going to be talking about how to find a change in energy coming from a wave, or sort of the energy generated by a wave, we should say. So we've got a string, and the string has a length of L, and it has a mass of M. And we're also given a wave equation for this string, so we're told its y position as a function of its x position and its t position. And that just comes in the form of this constant times a cosine of some things. And our goal is, over this time period of delta t equals tau, we're supposed to find the energy generated by this wave. And so the first thing I think of when I think of waves and getting energy is power, because when it comes to waves on strings, I know how to find the power of a wave, and I know that that's quickly relatable to energy. I know that the energy's derivative with respect to time is power, so I know if I have the average power, which is actually what this equation solves for, and I multiply it by the change in t, I will actually get the change in energy. So I pull out this equation, which we can see on our equation sheet. It's 1/2 mu omega squared a squared times v. So our goal is going to be to find this power and then multiply it by our change in t. And then we have our change in e, and that's all we have to do. So we just have to look closely at this stuff and pick out all these variables. So for power, let's start. We've got the 1/2. We didn't have to do any work. Next is mu. I know mu is a mass per unit length. I've got a mass and I've got a length, so let's just throw in the mass per length, m over L. Now omega. So for omega, we can actually use this y equation right here. So I've written the y equation over here in general form. You may notice there's a delta over here and there's a sign right here versus no delta and no sign. But that's okay, because all the delta does is give us freedom as to choose whether it's a sine or a cosine. For instance, if I plug in 0 in this equation, I get a sine. If I plug in 0 for delta. If I plug in pi over 2 for delta, I get a cosine or a minus cosine or something like that. But I can control what it is. So if we have one, and it's good the way it is, let's not even worry about the delta or the sine or whatever. So, omega, I know, is the thing sitting next to t. And b is the thing sitting next to t. They're both minus signs, so I won't even worry about that. We're just going to get omega equals b. So let's throw in a b squared. Next, a, exact same way, is sitting out front. D is sitting out front. Let's get a d squared. And then last is v. So I know that v is something like frequency times wavelength. And I also know that I can write it as omega over k. And so if v equals omega over k, we said omega is b, k is a, so don't be confusing this variable a for this constant a. So omega over k is going to be b over a. And then, just like we said before, we're just going to take this power average and we're going to multiply by delta t, which we call tau. So I'm going to rename this right here to be energy, and I'm going to throw in a time change tau. And once we have this, we're all done with the problem. That's our answer. That's all we have to do.